Hey everyone, welcome to the lecture series of Elementary Classical Mechanics, where we will embark our journey from basic to advanced physics. In this lecture, we will discuss about average speed and velocity in one dimension. This concept will tell us that overall how fast the object will go, where we will be well understood if distance and displacement concept are absolutely clear. So let's get started. Let us revise the concept of last lecture. Displacement, which has both magnitude and direction, is defined as change in position and is mathematically represented as x sub f minus x sub I, where x sub f and x sub I being the final position and the initial position in one dimension respectively. Distance, which consists of only magnitude, is the total journey taken by the particle. Average velocity is a vector quantity. That means this quantity has both magnitude and direction, just like displacement. Its unit is meter per second. Velocity of an object, if defined in a simpler manner, then it will be how fast an object has traveled. That is why the unit is like meter per second. That is, in how much meter an object travels in 1 second, or how much length a person covers in a particular time. Average velocity is defined as rate of change of displacement and mathematically represented as delta x divided by delta t, where delta x and delta t being the change in position and change in time respectively. Delta x is written as x sub f and x sub I, where x sub f and x sub I is the final and initial position of a particle respectively, and delta t is written as t sub f minus t sub I, final and initial time. Now let us understand the concept of average velocity by an example. We will understand this concept graphically. On the x-axis is time from 0 to 9 seconds. On y-axis is position from negative of 2 to positive of 5 in meters. A particle travels in this particular way such that we intercept 3 points for this particular problem. At time t equals to 0 second, particle is at position negative of 2 meters, and then at 0 meters in 3rd second till 4 meter in 6th second. We can intercept any point in between, but for the convenience of this problem, I have considered only 3 points. Now we know the 3 intercepts. Let us name them A, B and C. Let us calculate the average velocity for a path AB, which will be delta x upon delta t. Delta x will be final position minus initial position, and similarly delta t will be final time minus initial time. From the graph, we substitute x sub f as 0 meter and x sub I as minus 2 meter, and t sub f as 3 second and t sub I as 0 second respectively. We get average velocity as 0.67 meter per second. That is, for a path AB, the particle has covered 0.67 meter in 1 second, or 67 centimeter in 1 second. Similarly, we find the average velocity of path BC. Again, we substitute the value of initial and final values of position and time, and thus we get average velocity as 1.33 meters per second. Now in the next case, can you find the average velocity for path AC? Please pause the video and try it out yourself. And this is how path AC's average velocity is calculated. Average velocity will give us both magnitude and direction. So in this example, particle has traveled in positive direction for all the 3 paths. Average velocity for the whole path AC is the largest, which is 2 meter per second, and the least average velocity is taken by path AB is 0.67 meter per second. Average speed is the total distance traveled by the particle in an interval of time. Its unit is meter per second. Even though its unit is same as average velocity, Average speed is a scalar quantity, which means it will give only magnitude. Mathematically, it is represented as the total distance traveled by the time or the change of time. Let us understand with the help of an example. A guy walks 10 meters in 6 minutes and return back 5 meters in 3 minutes. We need to find the average speed of this guy. First, the guy takes 10 meters in 6 minutes, then comes back and covers 5 meters in 3 minutes. Now, for the average speed, this person walks for the first trip for 10 meters in 6 minutes and then returns back for 5 meters in 3 minutes. Therefore, the total distance traveled by that person will be 15 meters and time he took to complete his journey will be 3 plus 6 9 minutes. Calculating, we will get 15 meters divided by 9 minutes, which will be 1.67 meters per minute or 0.0278 meter per second. In this lecture, I have talked about some new terms like scalar and vector, which we will take in the later lecture briefly. These are broad topics and need separate explanation. Here in this lecture, I have emphasized these terms due to the requirement of topic. For the meantime, just remember that scalar quantity will just give us magnitude in the result of problem, and vector quantity will give both magnitude and direction for the output of the problem.